Alright, so this is going to be the last video. We'll move through it kind of quick at this point. Hopefully you're getting a better feel for how to take a research paper and turn it into functional code to do the testing. Our last little bit that we're going to work on is calculating our deltas. Let's see, I want to be, I forgot to just bring up the paper real quick. Make sure everybody understands where we're at. So what we're trying to do here is calculate our different deltas and then also go ahead and calculate our theta variables, and then we'll export those numbers to the spreadsheet, and then you can go ahead and complete the table as is. This is my code position right now. This is where we finished up with our export. In this case, what we want to do is go ahead and do our calculation. One of the things I need is the return mean, and I need it to be on every line of code or in the database. There's two ways to do this, two nice little tricks that can become valuable for you. This is the first one. We're going to create a database called delfset. We're going to use a retain statement. Remember, what retain does is that when a new observation comes up, instead of all the values being set to missing, the retain sets it to the previous value. We're going to use a conditional set here. So if we're underscore n underscore, meaning if we're on the first observation, we're going to set my pvar. And then beyond that, we're going to go ahead and set this progressive aggregate data set that we already created. Then we're going to run through and drop a couple of variables out of it, and we're going to set the return mean equal to return mean, and that is basically just going to create the exact same value of return mean all the way through the data set. So I'm going to go ahead and run this. Another thing I recommend that you do is on the view here. A lot of times it's better just to do a list. You see more what's going on, and it's just, to me, I think it's easier. So I'm going to go ahead and run this. So now I've created the variable delfset, and what you see is return mean has been copied down along every one of the observation positions, and we need that because our equation requires the mean to be subtracted, so we need to know what the average is on every one of our valuations as we go through the process. Alright, so I can go ahead and exit that. That's just one way to get it done. Another thing is this call of simput. So what we're going to do is create this data set, put sim. Let me run it, and if we take a look at it, there's only one observation in it, and what I want is the return mean. So what this call simput does is this is now a macro variable called our mean, and its value has been set to return mean, and you can use this %put function, run that, and then if you look in the log, it's run the %put, and this is the value that's set in there. So in that case, I can always just reference the @ourMean variable, and that's going to be my mean all the way through the analysis. So then we're just going to apply the equation. Our initial delf is just return minus the mean squared, and then delf1 is the previous delf times the lag, and then delf2 is previous delf times the lag, etc., etc. So this is a progressive summation that's going on. The equation calls us for sum up every one of these variables, which is just what this proc means is doing, and it creates an output file here called LoMacStep5. So I'll go ahead and run this data step. Going a little quicker here because I don't think you need to watch me type anymore. We'll check our log and make sure that everything worked out okay. And again, these missing values are because there aren't enough lags, right? We're doing 16 lags, so some of the values aren't being calculated until towards the end. All right, and then this is our adjustment on Delph, again, finding the value of each one being adjusted for as indicated in the paper, right? So we're just following the equations that are in the paper. So I'll go ahead and run this one, and finally we're going to do our theta set. So if n is less than 2, then we're going to calculate our theta. Oh yeah, I want to put up this one. Our proc transpose LoMacStep5 out LoMacStep5. Proc transpose takes a column and turns it into a row, or a row and turns it into a column. So we'll just take a look at LoMacStep5 here. So what we had initially was a big row, and now what we have is a column, so that we can do our calculations as we move down. All right, so these are then what I do for my theta calculations, theta 2, theta 4, theta 8, and theta 16. Excuse me. And then we're going to go ahead and sum out everything again. I need that sum to be in there. And then we're going to go ahead and export. So we'll just run our final little setup here and check that everything ran okay. So I've got my proc export taken care of. And at this point, I now have a completed table. And then this is for my original run, but back in 2006. So we're just, again, our Z-stat becomes, let me double click here. So our MR2, right, square root of B11, so we're taking the square root of the number of observations times our MR2 divided by the square root of our theta, which is this calculation right down here. All right, so we have 0 mean. What we get is a straight z-score from it, and then we can calculate all of our probabilities. All right, so this last video was nice and quick. It's going to take you a while to type in all the material that you're going to need from an equation standpoint. Remember, you can always pause the video anytime you want. You'll learn a bunch of different interesting, I think, things. The proc export, the way you build your tables automatically. It creates a lot easier to edit. Just understanding, you know, if a paper calls for a sum, how you do a summation in Excel. Excuse me, in SAS. And then conditional if statements and controls, the retain statement, and then of course your simput or this other statement up here in order to have numbers come in appropriately. All right, well, we'll probably do another project that's more regression based, again following some existing research paper. All right, well, thank you very much. Excuse me. And again, I hope you enjoy the class.